Welcome back to the channel. Today we will discuss about one of the most fundamental key concepts in data structure, complete binary trees. Okay, before discussing the complete binary tree, let's start from the basics. What is the difference between a tree and a binary tree? In a tree, each element can have any number of subtrees. But in a binary tree, each element can have at most 2 subtrees. In a tree, the subtrees are unordered. But in a binary tree, all the subtrees are in an order. So that is the difference between a tree and a binary tree. So what is this complete binary tree? This binary tree is divided into 2 parts, a full binary tree and a complete binary tree. Today we will be discussing about this complete binary tree. Let's move on. Okay, now let's discuss about complete binary trees. A complete binary tree is a binary tree that satisfies 3 properties. The first property is, in a complete binary tree, every level except possibly the last level is completely filled. So this level should be filled except for the last. This complete binary tree is correct. If we erase this one, it is still correct. If we erase this one also, it is still correct. But if we erase this one also, since the last level, there are no level below, the last level is completely filled, each have subtrees, this is not a complete binary tree. So in a complete binary tree, the last level should be filled at least like this. Now let's move on to the second property. Okay. The second property of a complete binary tree is all nodes appear as far left as possible. So as you can see in this complete binary tree, these child nodes appear as far left. For example, if we have these child nodes, instead of from here, if we have them from here, it is an incomplete and incorrect completely filled binary tree. Because this is not as far left as possible, this is not a complete binary tree. So every node should be as far left as possible. That is the correct way of, and that is the second property of complete binary tree. Now let's move on to the third. Okay. The third and the final condition that should be satisfied in order to a binary tree to become a complete binary tree is each non-leaf node has exactly 2 child nodes. Before that, let's discuss what a non-leaf node is. As you know, these are nodes. A leaf node is a node which do not have any children. As you can see, this element doesn't have any children. So this is known as a leaf node, and a non-leaf node is a node which do have children. So as it is stated here, every non-leaf node has exactly 2 children, not more, not less, exactly 2 children. As you can see in this complete binary tree diagram, each non-leaf node has exactly 2 children. For an example, if we do this, this has only one child node, this is incorrect. This is not a complete binary tree. So if we erase this, now this is a correct complete binary diagram. As you can see, every non-leaf node must have exactly 2 child nodes. Those are the three conditions that should be satisfied in a binary so that it becomes a complete binary tree. Now let's move on. Now let's discuss the method to find the value of child nodes of a parent node. There is a method to it. A parent node, let's put the value k, and for the left child the value is 2k, and for the right child the value is 2k plus 1. Let's do an example. Let's say we want to find the left and right child of this parent node. Assume that we don't know this. So k is equal to 4. Let me use the black one. K is equal to 4. Therefore left child should be 2k. Therefore 2 multiplied by k. 4 multiplied by 2 is equal to 2 multiplied by 4 equal 8. And the right child should be 2k plus 1. 2k is 8. 8 plus 1 equal 9. So let's check if these answers are correct. The left child of this parent node is 8. So answer is correct. And the left child of and the right child of this parent node is 9. As you can see, both of our answers are correct. And that is the way to find the left child and right child value of a parent node. Now let's move on to the coding part.
Now let's jump into the Java implementation code of complete binary trees. By this full Java code, we check and construct a complete binary tree. As you can see here, I have written the entire code with comments. If you have any questions or any misunderstanding, you can pause the video and check the comments for further explanations. Now let me explain the code slightly from the beginning. We have imported the necessary libraries. After that, in here we have defined the tree node structure. After that, this initializes the left and right children as well. Now this entire code has 4 steps. Now let's go to the second step. The second step, implement checking for a complete binary tree. This is the root of the binary tree, and this function is to check if the binary tree is complete or not. If the binary tree is not equal to none and empty, it is an empty tree. An empty tree is always a binary complete tree. And now this flag helps to detect a null node, and there's a while loop. This processes the front node in queue, and there's a if condition as well as an if else clause. If we find a null node, we mark the flag. If a non-null mode appears after a null, it's not complete. It's such a simple if condition. Then we continue level loaded traversal and returns if we complete traversal without a violation, it's a complete binary tree. Now below is the public static void main. This is the main algorithm, main function. And here we have introduced a new tree called binary tree. We have used the tree variable here, and we have inserted the necessary tree nodes. For this we have inserted 1, and for the left 2, and for the left of the left child 4, and right child 5, and left child 6, and we have inserted the necessary values of each node. Then we have inserted the if and else condition to check whether if the tree is complete or not. Now we have called the function. If it is complete, if the function checks out and it is successful, this statement is print: the binary tree is complete. Else, it is not a complete binary tree. This statement is printed. The binary tree is not complete. And the third step is it constructs a binary tree using an array. As you can see here, there's an array representation. And this display the tree stored as an array, as you can see. Now the last and final step for constructing a complete binary tree using an array. Here, this is the array representation of the tree, and this is the constructor to initialize a tree form array, and this prints the tree as an array. Now let me run this code. Okay, as you can see, our inserted tree is a complete binary tree, and the binary tree is stored in the array. Tree is stored in the array like this. It is also correct. Now let me give a slight summary of the entire code. This code checks for a complete binary tree. Level loaded traversal using a queue to process each node. If you find a null node, all following node must also be null. If a non-null node appears after a null node, the tree is not complete. It is such a simple process. And to construct a complete binary tree using an array, level loaded storage nodes are stored sequentially. Direct array access, the representation is used for heaps, priority queues, binary search trees. Now that's all for the coding part.
Today we learned about complete binary trees, how nodes are arranged in levels, what is the difference between a complete binary tree and an incomplete binary tree, and the relevant coding parts. Complete binary trees are heavily used in heaps, priority queues and databases. If you found this video helpful, please make sure to like and subscribe. See you in our next video. Thanks for watching.